In the last lesson, you were introduced to the topic of proofs. And in this lesson, we are going to get into a little more detail. So in this lesson, we are going to learn the kinds of reasons that can be used in proofs. And then using that information, we are going to prove the midpoint theorem and the angle bisector theorems. Then at the end, we'll show you how to use those theorems for other proofs. Now, when you're proving theorems, there are 4 things that you can use to prove a statement to be true. Those 4 things are given information. We can also use definitions. We can use postulates, which, remember, are just statements that do not need to be proven. And then we will be able to use theorems as well. Theorems, however, need to be proven first before you are allowed to use them. And let me take a moment to pause and emphasize the importance of memorizing your definitions and postulates. Because if you do not have those memorized, there's no possible way that you can perform a proof. Because that is what you're going to need to prove something to be true here in geometry. So if you do not know your definitions and postulates, make sure that you take a few moments and brush up on some of those. Without further ado, we're going to jump in and we will first go over 2 definitions which we will use to prove these different theorems to be true. The definitions you need to know are the definitions of midpoint, and then the other one's going to be an angle bisector. A midpoint is simply a point in the middle. It is a point in the middle of a segment that creates 2 equal or congruent segments. So for example, here is a segment AB which has a point M in the middle. And let's say that AM and MB both were 5 inches. Then we can conclude that M truly is the midpoint of AB because it has created 2 congruent segments, where AM is congruent or equal to MB. The other definition is an angle bisector, which is analogous to the midpoint. The only difference is this is with an angle, midpoint is with a segment. An angle bisector is something that creates 2 congruent angles. So for example, here we have the angle ABC, and then we have this ray BD that cuts it in half, where now angle ABD is congruent or equal to angle DBC. So therefore, BD is the bisector of the angle ABC, because BD is creating those 2 congruent angles. So now, given the definition of midpoint, we are going to prove what is called the midpoint theorem. So the midpoint theorem says that if M is the midpoint of a segment, then AM would be 1/2 of AB, and MB is 1/2 of AB. Which makes sense, right? If AB, for example, were 10 inches or 10 feet, and M were the midpoint, then AM would be 1/2 of AB. AM would be 5 when AB is 10. So conceptually, that makes sense. But we need to prove that. And to prove that, we're going to have 2 columns. We have a statements and a reasons column. The first statement and reason will typically always be your given information. So what is given? What do we know? Well, what we know is that M is the midpoint of segment AB. That is what we know. And the reason is just given to you. That is a given statement of fact. And then what we're trying to prove, so the last statement that we're trying to end up at is going to be AM equals 1/2 AB and MB equals 1/2 AB. Now, when you're proving something, a great place to begin is by using the given information. So if we know that M is the midpoint of AB, what does that tell us? Well, we just stated the definition of midpoint. So based off the definition of midpoint, we can logically conclude that AM the segment AM is congruent to segment MB, or the length of AM is equal to the length of MB. By the way, these are different statements. Don't forget that the shapes are represented by the shape symbol above it. So this is saying that the shape of segment AM is congruent to the shape of the segment MB. Shapes are congruent, whereas here there's no line above it. So therefore, what that means is that the length of those segments are equal to each other. So lengths are numbers are equal, whereas the shapes are going to be congruent. So we can say both statements because of the definition of midpoint. And that's your reason. That's the definition of midpoint. So now the question is, where do we go from here? Well, notice at the end, we need to somehow get the entire segment of AB into this equation. So maybe if we were to put AM and MB together, well, then that would give us the entire segment AB. So that would be another good step to take. If we were to put together AM and MB, if you were to add those together, that's going to equal the measure of AB. So that would be a good next step. You add the smaller segments, AM plus MB, to equal the bigger segment of the entire length of AB. Now, what is the reason for that? What says that we can add the smaller parts of the segment together to get a bigger part? And that's going to be the segment addition postulate. So once again, make sure you know your postulates, because if you don't, you will never get these reasons or statements. Now from here, what we can do is we can use the fact that AM equals MB. So in place of MB, right here, I can put in AM. So now we have AM plus AM equals AB. And AM plus AM would be the same thing as 2AM. Now what is the reason for that one? Well, what we're doing is we are substituting AM in place of MB. So that would be your substitution property. And then from here, if we just solve this for AM by dividing both sides by 2, then we have AM equals 1/2 of AB. And notice that is what we were trying to end up proving, was that AM equals 1/2 AB. Now the reason for that is because we are dividing the same thing by both sides, which would be the division property. So we're basically done. AM equals 1/2 AB, but then we also had to prove that MB equals 1/2 AB. So if we just replace AM with an MB, then we have the same, the second part of this statement. So in place of AM, I'm going to put in MB because they're the same thing. Right up here, AM equals MB. So in place of AM, I put MB, and the reason is because I'm substituting. I'm substituting MB in place of AM. So we are done. We have both statements that we were trying to prove, and we have all the steps, all the reasons, and we are finished with the midpoint theorem. Now I'm going to walk you through another theorem, so one more theorem, and then we are going to give one example at the end using these theorems in another proof. So we have also what's called the angle bisector theorem, which is basically identical to the midpoint theorem. The only difference is here we are dealing with angles instead of midpoints. So the process for proving this one is going to be the same kind of process that we just used for the segments. So the bisector theorem says that if you have the ray BX that bisects the bigger angle ABC, then the measure of angle ABX, so right here, this angle, would be 1/2 of the big angle, and XBC would be 1/2 of the big angle as well. So before we can use theorems, we need to prove them. So let's prove this one. We have a statements and a reasons column. We begin with the given information. So we are told that ray BX is the bisector of angle ABC. That is your given statement. So we just write that down. Ray BX is the bisector of angle ABC, and that is because it is given to us. Now, just like in the midpoint theorem, the next step will be based off our definition. And that's always a good step to take with any proof, not just these ones. But we know that BX is the bisector. Well, what does bisector mean? Well, a bisector is going to cut the bigger angle in half so that we have two congruent angles. So we can say that angle ABX, this angle right here, is congruent to XBC, this angle. Or we can also say the measure of those angles are equal. Once again, don't forget that angles are a shape, and shapes are always congruent. So shapes are congruent, never equal, but the measure of the angles could be equal. So the measure of the angle would be a number. Numbers are equal, whereas shapes will be congruent, not equal. So the reason for that one is just because of the definition of bisector. Bisector means that we have two congruent angles. Now from here, we know that at the end, we need to put them together somehow to get measure of angle ABC into the picture. So what I can do is I can say that if I take ABX plus XBC, if I take those two angles, put them together, I'm going to get the bigger angle of angle ABC. So if I add those two measures together, I get the measure of angle ABC. And the reason for this one is the angle, sorry, it should be angle addition postulate. It should be angle addition postulate. Okay? So once again, make sure you know your definitions, make sure you know your postulates. Now from here, we see that ABX is equal to XBC. So in place of XBC, I can put in measure of angle ABX. I can substitute that measure in. So what I have now would be measure of angle ABX plus measure of another angle ABX would equal the measure of angle ABC. Or we can say that we have two measures of ABX equals measure of angle ABC. And the reason for that is because we are substituting. We are substituting ABX in place of XBC. So now from here, all I need to do is look at this bottom equation and divide both sides by 2. When I divide both sides by 2, what I have is measure of angle ABX equals then 1/2 measure of angle ABC. And the reason for that one is because I'm dividing both sides by the same number, which would be your division property. And that is what we're trying to prove, right? Measure of angle ABX equals 1/2 measure of angle ABC. So we are basically done, but then just don't forget about the second part over here. So the second part over here, all I need to do is replace the measure of angle ABX with a measure of angle XBC. So in place of ABX, I'm going to put in XBC because they're equal, right? Looking back up here, those are equal. So I have measure of angle XBC equals 1/2 measure of angle ABC, and that is because I'm substituting. And we are done with this proof. So once again, make sure you know your definitions, make sure you know your postulates, and now that we have this theorem proven, after this lesson, we can use these theorems to prove other things. And now, there is a little nuance between definitions and between the theorems. So the midpoint and bisector definition have to do with both portions being equal. So the definitions deal with the segments or angles being equal. And now we just learned the midpoint and bisector theorem. So the theorems say that each side is 1/2 of the total. So the theorem talks about 1/2 of the measure for the angle and for the segment. So don't forget the difference. It's a very small difference, but there is a difference between the definitions and between the theorems. Definitions deal with equals, theorems deal with 1/2. And now let's look at one example where we can use those theorems to prove another proof. So this proof has 3 parts that are given to us. We are told that BD, this right here, is a bisector of angle ABC. We know that FH is a bisector of EFG, and we are told that the measure of angle DBC is equal to the measure of angle HFG. And now for a proof, we need a statements column and a reasons column. And the first statement should almost always be the given information. So all 3 of these statements right here, we're going to put as your first statement. So all 3 of those are given, and that's going to be the reason for that first statement. Now a good next step will almost always be by using the different words that are used in the statement. So for example, here we see the word bisector. So we see the word bisector. Now with bisector, we know a definition and we now know a theorem. So based off that word bisector, we can use either the definition or the theorem. So which one should we use in this case? Well, notice my end goal is to get ABC and EFG in the picture. ABC is the bigger angle, EFG is the bigger angle. Well, the midpoint or bisector theorem relates the small angle as being 1/2 of the bigger angle. So if we use a theorem, it's going to put in the equation the bigger angle ABC and EFG. So based off the theorem, I can say that measure of angle DBC, this angle, that's going to be 1/2 the bigger angle ABC. And the measure of angle HFG over here is equal to 1/2 the measure of EFG. So notice we wanted ABC and EFG into the equation, and now we have ABC and EFG into the proof. And the reason for this is going to be your angle bisector theorem. Now the question is, where do I go from here? Well, what I can do is I can now, in place of measure of angle DBC, I can replace that with 1/2 measure of angle ABC. I can substitute that in. And in place of HFG, I can now put in 1/2 measure of angle EFG. Those are the same thing. So I'm substituting those in to get this next step. And the reason would be substitution. Notice we're almost done. All we need to do is get rid of the 1/2 in front, and we have the statement that we're trying to prove. So how do we get rid of the 1/2 on both sides? Well, I can multiply both sides by 2. Multiply this by 2, I get 1 measure of angle ABC, and multiply this side by 2, we'd have 1 measure of angle EFG. So we have our proven statement, the one we're trying to prove, and the reason would be based off multiplication. And we're done. We have used the given information to logically walk through to the point where measure of angle ABC is equal to the measure of EFG. So we are done with this proof. We are done with the lesson for today, and we will see you next time.